Non-contact voltage detectors are essential tools for electricians and anyone working with electrical circuits. They provide a safe and convenient way to detect the presence of voltage without making direct contact with live wires. Several models are available on the market, each with its own set of features, pros and cons. One popular option is the Klein Tools NCVT-2 non-contact voltage tester. This tester features dual sensitivity, allowing it to detect voltage from 12 to 1000 volts alternating current and 70 to 1000 volts direct current. It automatically adjusts to detect voltage without the need for user adjustments. A bright light emitting diode, or LED, indicator flashes and emits audible signals to indicate voltage. The device retains the last voltage detected for easy reference and is rated Category 4 600 volts, meeting industry standards for safety in high-energy electrical environments. The Klein Tools NCVT-2 offers accurate and reliable voltage detection, is easy to use with dual sensitivity levels as a bright and clear indicator for easy visibility, durable construction for long-lasting use, and is offered at an affordable price. However, it may not be suitable for detecting very low voltages below 12 volts. The price is around $20. Other recommended non-contact voltage detectors include the Fluke 1 AC-2 non-contact voltage tester, which is a high-precision tester with adjustable sensitivity levels. The Sperry Instruments HDV-1 non-contact voltage tester, a compact and easy-to-carry device with a bright LED indicator. The Martindale Electric VT50 non-contact voltage tester, which features a digital display for accurate voltage readings. And the Southwire SH120 non-contact voltage tester, an affordable and reliable tester with a high visibility LED. When choosing a non-contact voltage detector, consider the following factors. Firstly, voltage range. Ensure that the tester can detect the range of voltages you will be working with. Secondly, sensitivity. Look for a tester with adjustable sensitivity levels to avoid false readings. Thirdly, indicator. Choose a tester with a bright and clear indicator that is easy to see in various lighting conditions. Fourthly, safety rating. Select a tester with a Category 3 or Category 4 safety rating for use in high-energy electrical environments. Fifthly, durability. Opt for a tester with durable construction that can withstand the rigors of daily use. Sixthly, price. Consider your budget and choose a tester that offers the best value for your money. Non-contact voltage detectors utilize capacitive coupling to detect the presence of alternating current voltage. When the probe of the detector is brought near a live conductor, the alternating current voltage creates an electric field that induces a small current in the detector's circuitry. This current is then amplified and used to trigger an audible or visual alert indicating the presence of voltage. The sensitivity of a non-contact voltage detector is determined by the strength of the electric field it can detect. More sensitive detectors can detect weaker electric fields, allowing them to detect voltage from a greater distance or through thicker insulation. However, highly sensitive detectors may also be more prone to false readings caused by stray electromagnetic interference. Non-contact voltage detectors are designed to detect alternating current voltage, but some models can also detect direct current voltage. Direct current voltage detection typically requires a different sensing method, such as electrostatic field sensing. When using a non-contact voltage detector, it is important to follow these safety precautions. Firstly, always test the detector on a known live circuit before using it to verify its functionality. Secondly, do not use the detector in wet or damp environments. Thirdly, do not use the detector if it is damaged or malfunctioning. Fourthly, keep your fingers and hands away from the probe tip while using the detector. Fifthly, always de-energize the circuit before working on it whenever possible. Sixthly, follow all applicable safety regulations and guidelines. Non-contact voltage detectors are valuable tools, but they should not be considered a substitute for proper electrical safety practices. Always use caution when working with electricity and consult with a qualified electrician if you have any doubts or concerns. Understanding alternating current and direct current is fundamental to understanding how non-contact voltage detectors function. Alternating current is characterized by its periodic change in direction, typically following a sinusoidal waveform. This change in direction creates an electromagnetic field around the conductor, which is the principle upon which alternating current non-contact voltage detectors operate. Direct current, on the other hand, flows in one direction only, resulting in a static electric field. Detecting direct current voltage using non-contact methods often involves sensing the presence of this static field, which requires different and sometimes more complex circuitry. The category rating of a non-contact voltage detector indicates the level of over-voltage protection it provides. Category 3 rated devices are designed for measurements performed in building installations, while Category 4 rated devices are suitable for measurements at the source of the low-voltage installation. Choosing the correct category rating is crucial for ensuring the safety of the user and preventing damage to the equipment. The accuracy of a non-contact voltage detector can be affected by several factors, including the distance from the conductor, the type of insulation, and the presence of electromagnetic interference. To ensure accurate readings, it is important to hold the detector as close as possible to the conductor and to avoid sources of interference. Some detectors also have adjustable sensitivity settings that can be used to optimize performance in different environments. Regular maintenance of a non-contact voltage detector is essential for ensuring its continued accuracy and reliability. This includes cleaning the probe tip, replacing batteries as needed, and storing the device in a dry and protected environment. It is also important to periodically test the detector on a known live circuit to verify its functionality. In addition to the basic function of detecting voltage, some non-contact voltage detectors offer additional features such as continuity testing, resistance measurement, and capacitance measurement. These features can be useful for troubleshooting electrical circuits and identifying faulty components. However, it is important to note that these additional features may not be as accurate as dedicated instruments designed for those specific measurements. When working with electrical circuits, it is always important to wear appropriate personal protective equipment, or PPE, including safety glasses, gloves, and insulated footwear. This equipment can help to protect you from electric shock, burns, and other injuries. It is also important to be aware of the potential hazards associated with working with electricity, such as arc flash and electrocution, and to take appropriate precautions to mitigate those risks. Non-contact voltage detectors are useful tools for identifying energized circuits, but they should not be used as the sole means of verifying that a circuit is de-energized. Always use a properly rated voltage tester to confirm that a circuit is de-energized before working on it. It is also important to follow lockout-tagout procedures to prevent accidental re-energization of the circuit. Lockout-tagout involves disconnecting the circuit from its power source and attaching a lock and tag to the disconnect switch to prevent it from being turned back on. Understanding the National Electrical Code, or NEC, is essential for anyone working with electrical circuit. The NEC provides guidelines for safe electrical installations and helps to prevent electrical hazards. It is important to be familiar with the NEC requirements that apply to your specific work environment and to follow those requirements carefully. When selecting a non-contact voltage detector, it is important to consider the specific application for which it will be used. For example, electricians who work in industrial environments may need a more rugged and durable detector than homeowners who only use it occasionally. It is also important to consider the voltage range and sensitivity requirements of the application. Non-contact voltage detectors are constantly evolving, with new models offering improved features and performance. Some recent innovations include detectors with wireless connectivity, which allow users to transmit data to their smartphones or tablets, and detectors with built-in cameras, which allow users to capture images of the circuits they are testing. These advancements are making non-contact voltage detectors more versatile and user-friendly. Remember that while non-contact voltage detectors are designed to detect voltage without direct contact, they are not foolproof. Factors such as shielded wiring, deeply buried cables, or thick insulation can impede accurate detection. Therefore, always use these tools in conjunction with other safety measures. Before using a non-contact voltage detector, inspect it for any signs of damage, such as cracks, breaks, or loose parts. If the detector is damaged, do not use it. Replace it with a new one. Battery life is a critical factor in the usability of a non-contact voltage detector. Choose a detector with a long battery life or one that uses readily available batteries. Some detectors also have a low battery indicator to alert you when the batteries need to be replaced. Many non-contact voltage detectors have an audible alert, such as a beep or a buzz, that indicates the presence of voltage. The loudness and tone of the alert can vary depending on the model. Choose a detector with an alert that is easily audible in your work environment. Some non-contact voltage detectors have a visual alert, such as a flashing light or an illuminated display that indicates the presence of voltage. The brightness and color of the alert can vary depending on the model. Choose a detector with an alert that is easily visible in your work environment. The size and weight of a non-contact voltage detector can affect its usability, especially for prolonged use. Choose a detector that is comfortable to hold and easy to carry. Some detectors have a pocket clip or a belt loop for added convenience. When storing a non-contact voltage detector, keep it in a clean and dry place away from extreme temperatures and humidity. This will help to prolong its life and ensure its accuracy. Non-contact voltage detectors are not designed to measure the amount of voltage present in a circuit. They only indicate the presence or absence of voltage. To measure the amount of voltage, you need to use a multimeter or other voltage measuring instrument. Before working on any electrical circuit, always disconnect the power source and verify that the circuit is de-energized using a properly rated voltage tester. This will help to prevent electric shock and other injuries. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Always follow all applicable safety regulations and guidelines when working with electricity. This will help to ensure a safe working environment.